Math lesson number 45, Triangle Congruence. Figures with the same shape and size are called congruent figures. So two segments are congruent if and only if their lengths are equal. So in this figure, the length of segment AB is 15, the length of segment CD is 15 centimeters. Therefore, the two segments are congruent. Now let's proceed to angles. Two angles are congruent if and only if their measures are equal. So in this figure, in this angle, angle B measures 40 degrees, angle E measures 40 degrees also. Therefore, angle B is congruent to angle E. Or angle ABC is congruent to angle DEF. Now, let's have triangles. Two triangles are congruent if and only if their corresponding angles and sides are congruent. So in this figure, A or angle A corresponds to angle D. They have the same measurements. Angle B corresponds to angle E. Angle C corresponds to angle F. And for the sides, side AB corresponds to side DE. Side AC corresponds to side DF. And side BC corresponds to side EF. So all the corresponding parts are congruent. Therefore, triangle ABC is congruent to triangle DEF. Let's have example. Given that triangle ANG is congruent to triangle LES, find the missing angle measures. So in this figure, let's have the solution. Angle G is congruent to angle L. So meaning to say angle G corresponds to angle L. So if you're going to rotate this, wherein S should be in this position, and then E in this position, and then L in this position, then this figure will look like this. So G corresponds to angle L. Since angle G is equal to 82 degrees, then the measure of angle L is also 82 degrees. So this is 82 degrees. So angle N is congruent to angle E, meaning to say angle N corresponds to angle E. Since angle E is equal to 50 degrees, then angle N is also 50 degrees. Angle A corresponds to angle S. Since angle A measures 48 degrees, then angle S measures or will measure 48 degrees also. So once again, since the two triangles are congruent, all the corresponding parts are also congruent. Now let's have another one. Given that triangle ANG is congruent to triangle LES, now find the missing side lengths. So side lengths, GN, segment GN or side GN corresponds to side LE. Now, since LE is 5 centimeters, then GN is also 5 centimeters. AG corresponds to SL. Since SL is 6 centimeters, then AG is equal to 6 cm also. NA corresponds to side ES. Then ES is also 7 centimeters. So once again, since the two triangles are congruent, the corresponding parts are also congruent. Now let's have the triangle congruence. There are postulates and a theorem that can be used in order to conclude that the two triangles are congruent. So let's have the first postulate, the SSS postulate, or side congruence postulate. So if three sides of a triangle are congruent to the corresponding sides of another triangle, then the two triangles are congruent. So in this case, if AB is congruent to XY, BC is congruent to YZ, and AC is congruent to XZ, then triangle ABC is congruent to triangle XYZ by SSS congruence postulate. So that is SSS congruence postulate. So this is postulate, so we don't need to prove this anymore. This is already true. Let's have the second postulate, the side angle side congruence postulate. If two sides and an included angle, take note, an included angle is the angle between the two sides. So in this case, we have here the side and the side. This is the included angle. So once again, if two sides and an included angle of a triangle are congruent to the corresponding parts of another triangle, then the two triangles are congruent. So in this case, AC is congruent to QR, AB is congruent to RS, this angle, angle A, is congruent to angle R. Therefore, triangle ABC is congruent to triangle RSQ by SAS congruence postulate. Let's have the third postulate, the ASA congruence postulate, or angle side angle. So in this case, if two angles and an included side of a triangle are congruent to the corresponding parts of another triangle, then the two triangles are congruent. So in this case, we have here the angle and the angle, and between those angles we have the side. So that is angle side angle. So again, angle A is congruent to angle X, angle B is congruent to angle Y, side AB is congruent to side XY. Therefore, triangle ABC is congruent to triangle XYZ by angle side angle congruence postulate. Now let's have the theorem, the SAA congruence theorem. So side angle angle. If two angles and a side not included between the angles of a triangle are congruent to the corresponding sides of another triangle, then the two triangles are congruent. So let's take a look at this one. So this side here, SAA, so side angle angle. Take note, the side is not the included side. So once again, AC is congruent to XY, angle A is congruent to angle Y, angle B is congruent to angle Z. Therefore, we can say the triangle ABC is congruent to triangle XYZ by SAA, or side angle angle congruence theorem. Let's have an example. So given angle A in this figure, angle A and angle T are right angles. So angle A and angle T are right angles. I is the midpoint of AT. Okay, I is the midpoint of AT. Now angle F is congruent to angle H. Angle F is congruent to angle H. Prove that triangle FAI is congruent to triangle HDI. So let's have the solution. First, let's write the statement. Angle A and angle T are right angles, and that is given. Next, the measure of angle A is equal to 90 degrees. The measure of angle T is equal to 90 degrees also. Because the reason, definition of right angles. The measure of angle A is congruent or equal to the measure of angle T. And that is substitution, because 90 is equal to the measure of angle t. So you just substitute the measure of angle t to 90. So as a result, you have the measure of angle A is equal to the measure of angle t. So the reason is substitution. Next, angle A is congruent to angle t. Because the measure of angle A is equal to the measure of angle t, then angle A is congruent to angle t. That is the definition of congruent angles. So we have now angle A and angle t. So we have now angle. Okay. Next, I is the midpoint of AN, and that is given. AT. I is the midpoint of AT, and that is given. So AI is congruent to TI. Again, AI is congruent to TI. So AI is congruent to TI, and that is because of the definition of midpoint. So we have now angle and then side. Angle and then side. Next, angle F is congruent to angle H, and that is given. So we have now side angle angle, side angle angle. So therefore, we can say that triangle FAI is congruent to triangle HTI by Saa Congruence Theorem. Let's have another example. Given HP bisects angle EHO. So this is HP. HP bisects EPO. So HP also bisects EPO. Prove that side EP, so this one side EP is congruent to side OP. This one here. So we need to prove. Let's have the solution. So first, HP bisects EHO, and that is given. And because of that, angle EHP, so this angle here is congruent to angle OHP. So this angle is congruent to this angle. And the reason is definition of bisector of an angle. Next, HP bisects EPO. So, and that is given. Now, because of that, EPH, angle EPH, this angle here is congruent to OPH, this angle here. And the reason is definition of bisector of an angle. So we have now angle, angle. Again, angle, angle. Now, HP, okay, is congruent to HP itself. And that is reflexive or reflexive property. That is reflexive property. So this side here is congruent to this side also. So we have now angle, side, angle. Again, angle, side, angle. So therefore, triangle HOP, so this triangle here is congruent to triangle HEP. The reason is ASA congruence postulate. So we have angle, side, angle. Now, finally, side EP is congruent to side OP. Why? Because since the two triangles are congruent, congruent parts of congruent triangles are also congruent. So that is the reason why side EP is congruent to side OP.